Hi again, everyone. Let's take a look at part D here. 5 minus 2i, multiplying with negative 1 plus I. Hopefully you had a chance to try it out. Let's see how it goes. So, of course, the key here to begin is to FOIL. Let's go through that one step at a time. So I've got 5 times negative 1. Then we'll do 5 times I, negative 2i times negative 1, finally negative 2i times positive I, and that should get you this negative 5 plus 5i plus 2i, and finally minus 2i squared. So, okay, looks good. You might start combining here in the next line. The big point though, I squared becomes a negative 1. I'm just keeping everything else the same. So we get to this, right? We have plus 2 on the end now. And now we can combine our like terms, combine your constants, combine your i's, and our final answer, we'll put the real number first, negative 3 plus 7i. There it is. Okay, what's up next? Part E. Similar to the previous one, but now you notice something interesting about the two complex numbers we're multiplying. They're identical, except one has a plus and one has a minus. 3 plus 5i and 3 minus 5i. Hopefully that looks familiar to you. We did something really similar when we were rationalizing denominators with square roots. These are called conjugates. And so I'll drop this a little bit. Conjugates, but in fact, because they're complex numbers, now we give them the name complex conjugates. But in order to simplify, our technique is going to be the same, and we'll just notice, hey, what happens when you multiply complex conjugates? Because it's gonna simplify really well. So if you FOIL, all right, 3 times 3, we have the 9. Let's show all the steps. 3 times negative 5i, positive 5i times 3, and positive 5i times negative 5i, 9 minus 15i plus 15i minus 25i squared. And right away, oh, when you're multiplying conjugates, those middle terms cancel out. So we can probably just, okay, these are going to wipe each other out. Also, my I squared becomes negative 1. So my next line, 9 minus 25 times negative 1. And if you simplify there, we got the answer 34. Now, this is really interesting. When you multiply complex conjugates, the answer is purely real. That imaginary part canceled out, and we just got a real number in the end. Kind of cool. That will come in handy for our last example. And if it's our last example, well, it's got to be division. We've done multiplication, subtraction. I'm doing this in the wrong order. We've done addition, subtraction, multiplication, and now division. So, all right. We're dividing these two complex numbers, 2 minus I divided by 4 plus 3i. And that looks pretty intimidating. Our goal is the same as any other simplify question. We're going to put this in the form a plus bi, a number plus a number times I. Believe it or not. Here's the trick. Just like when we were rationalizing denominators with square roots, it's exactly the same thinking. We need to multiply the top and the bottom by the same thing to get this I down here to disappear, essentially. So I'm going to set that up in the next line. That is a multiply. That's hard to see. we've got 2 minus I over 4 plus 3I. We need to multiply the top and the bottom by the same thing to get rid of that I in the denominator. Well, if you were watching for the last example, the trick, of course, is the conjugate. We're going to take the conjugate of our denominator, multiply by 4 minus 3I. And if I do that to the denominator, well, I got to do it to the numerator as well, so it doesn't change the value. And this is how we have to get started. It's kind of really nice. It's the same thinking, same approach as rationalizing a denominator if we had a square root. Okay, so what might be next? Well, we got a bit of work now. We need to FOIL our numerator. We need to FOIL our denominator. And I've done all that here. So let's talk through that. Well, numerator, 2 times 4, 2 times negative 3I, negative I times 4, negative I times negative 3I. Okay, and the denominator, 4 times 4, 4 times negative 3I, positive 3I times 4, positive 3I times negative 3I. There's all the pieces. We're going to start to clean it up. You might say, hey, our I squareds are going to turn into negative 1. We can also combine our middle terms. Well, these disappear in the bottom. And we'll wind up with this. So 2 things happening. Combining the i's, turning I squareds into negative 1 to both the top and the bottom. There you go. Now we're getting a lot simpler looking, right? We only have the one I now just in the top. If we keep going, combining these constants, well, 8 minus 3, 16 plus 9, we'll have something like this. 5 minus 10I all over 25. And you might think, perfect, I think we're done. Not quite. We have not yet, we've done a lot, but we have not yet reached our goal. A number plus a number times I. We have done it for the numerator, but the whole thing doesn't look like that. So here's what we're going to do. We're going to split this fraction. I'm going to put 5 over 25 as my first part, my real part, and 10I over 25 as my second part. Gonna write it like this. 5 over 25 minus 10 over 25, and I even put that I that would have been maybe in that numerator, I put it off to the side. So I have a number minus a number and the I on the side next to it. I got to be really careful to make sure this is in standard form. Then you may notice, hey, both of these can be reduced. Here's my final answer. 1/5 minus 2/5 and the I next to it. Well, it's a minus, but you could think of B as being negative 2/5. A plus BI, where A is 1/5, B is negative 2/5. There it is. We have the standard form of a complex number with division. There you go. That is the end of 8.8. Come to the live session. We can practice more of these or chat about any of these. Look for the videos on 8.3, the last section we're going to talk about. See you there.